Hello, this is a continuation of one of my previous videos. I'll put a link in the description to that one, so if you haven't seen that one you should probably watch that one first, otherwise some of what we're looking at here is not going to make a whole lot of sense. But just as a demonstration of what we're trying to achieve here, I have a couple of LEDs there. There's a yellow one and a red one, and I'm going to send an instruction from the cell phone to this GSM module which is connected to the Arduino, and we're going to tell one of those lights to turn on. In this case we will say the yellow light should go on. Now this is going to take a few seconds for the message to get through, but we should see the yellow LED go on there, and you can see what I've been doing here already, so you can probably get the idea from what we see on the side there, that we can sequence multiple of these commands if you like. So now I can do yellow off with a 0 and red on. Oops. So this should switch the yellow off and the red on. Like that. And well, I guess you get the idea, but just turn the yellow on and the red off. Again, that would be like this. So all we're doing here is using the Arduino to control some digital outputs, just to see that it's doing something, but you could connect this up to something a little bit more useful in real life. So let's have a look at the source code, because basically the rest of this video is just going to be looking at the source code, I'm afraid. Let's do a quick recap first of what happens when an SMS message arrives at the Arduino and how we can look at the content of that message. So I have this sketch loaded up onto the Arduino now, and all this does is relay whatever we type in the serial monitor to the SIM module, and whatever the SIM module gives to the Arduino, it'll just show us in this serial monitor directly. So we should have this responding. So this is just the ATOK, and like I say, look at my other video if you want to know what's going on here. So when I send a text, oops, hold on, what's going on here? Let's send a text ASDF, and just give that a moment, and we'll see that pop up in the serial monitor as a CMTI notification, and this is the storage type and the ID of that message. So that's ID number 1, and then to read that message we issue an AT plus CMGR, and then giving the ID of the message that we want to look at. So this will give us a couple of things here. It will firstly echo back the command that we just typed, and then it will give us a CMGR result with some parameters there, the date and the number that it was from, and then on the next line we have the content of the message. So we need to replicate what we just did here, these two commands, or one command really. We need to detect something incoming and then respond to it with that ID to look at the content of it. And I found that also it's a good idea in the sketch to, once you have process the content of the message, it's a good idea to do this too, CMGD for delete, and then delete the message with that ID, because if you don't do that, the phone only being able to store a certain number of text messages will just begin to ignore any incoming messages until the old ones have been deleted, and we don't want that. So in our sketch we're also going to issue this delete command for that purpose. So that's what we need to do. Now obviously this little sketch here is not going to do it, but let's have a look at the other sketch that I've written which does do it. Now I haven't put any comments on this sketch at the moment, so I'll have to do that before I upload it to the website for you, but we can have a look at it and see what it's doing. And how many lines have we got here? So it's about 250 lines of source code, so it's not a small sketch, which is a pity because people don't like to listen through explanations of this stuff, but nothing that it's doing is particularly complex. I'll just get rid of that servo. Actually, I was trying this with the servo just before, but it was pulling a little bit too much power off the Arduino for this. You need to have a decent amount of power for the SIM module as well, so it wasn't working out. But I was controlling a servo in the same way that I controlled those LEDs. Anyway, so we don't need that either, do we? Alright, so we have a software serial connection set up on pins 7 and 8, as in the last video. Now we have to keep track of what state we're in, because we're going to read in each byte that the SIM module gives us, and we have to figure out what to do with it. So what are we supposed to do when we see this comma, for example? Well, we have to know what state we're in when we see that comma. So there's a number of states, and I'll just quickly give a brief description. So detect message type is the default state that we start in, and in that state we're going to be looking for one of these two cases, the CMTI or the CMGR. Okay, and the next state is called ignoring command echo, and this is the state that we will go into when we see a line that starts with AT+, because any line that starts with AT+ that comes from the SIM module is just the SIM module echoing the command that we've given it. So basically we just want to ignore any lines that start with AT+. So that's what ignoring command echo state is. And then we have reading the CMTI storage type. So when we get a CMTI notification, you'll see that we have two parameters there. So there's the type and the message ID. So once we've detected that we are reading a CMTI message, then we'll go into this state, and then when we see a comma, then we'll switch into that state, and we know that the next part of the message is the ID. So in the same way, we have a bunch of these here for the CMGR, and I won't bother explaining them all because they're pretty much the same as what I just said for the CMTI one. But basically we're going to try and look for these commas, and whenever we see a comma, we can switch states, with the slight exception of the date. We can see that the date actually has a comma inside it. But fortunately the date is the last thing in that row. So once we've got to this comma, once we've found this comma, we'll just look for a new line character instead of looking for commas. And when we find a new line character there, we know that whatever comes next is going to be the content of the SMS message. Right, so we just have a byte variable to keep track of what state we're in right now, and we set that to detecting message type at the beginning. And we have a character buffer which we're going to read into, and we'll need to keep track of a certain number of bytes as we go to detect strings like this CMTI and so on. And we also need to know what position we're at in that buffer, so that as each byte is read in from the SIM module, we know what point in the buffer to place that at. And then we have a couple of global variables. Well, they're all global, I suppose. We're going to set this to the last received SMS ID, so that's going to be this one for this particular case. That would be 1. And then I've also made it so that you can check if the phone number that you're receiving the SMS from is one that you want to pay attention to, just so that you don't have any old person sending you texts and turning your LEDs off and on. So we'll keep track of that, and this is just a convenience function to set the buffer to all empty. Well, it sets every byte in the buffer to 0, and then it puts the position marker back to the beginning of the buffer. Right, so in the setup function we set up the software serial connection to the SIM module, and then we also start one up for the serial monitor there so that we can see something if we want to. And then I'm using pins 2 and 4 for those LEDs, so that's why I have pin mode settings there, and then digital write. I just turned these to high to begin with so that I could see that my LEDs were connected up properly. Oh, and the servo, yeah, we don't need that. Get rid of that. Okay, so at the beginning of the sketch, when we've done this initial setup, I have this loop here. Now this is going to do for integer I1 to 15. It's going to issue the mail delete command for mail IDs 1 to 15. So let's just upload this to the Arduino and we'll see that happening. Did that work? Yes. So if I we're a little bit late to catch it in the act, but if I scroll up a bit, you'll see what it was doing. Let me just restart the sketch. So we can see there it's just going through from 1 to 15, and it's deleting any SMS messages that might have been there already. Now I just found this a little bit more convenient than deleting them manually while I was developing. It just makes sure that there is nothing in the memory already that might cause it to get full. And I set it to 15 because I think I read somewhere that 15 is a typical number of messages to be able to store on the SIM card. My SIM card that I'm using, after I get to when I start using IDs above 10, it gives me error. So I think my SIM card is only able to store 10 SMS messages on the card, but that's fine. It just says error, but doesn't really cause a problem. Okay, in the loop function, that's here, we check if there are any incoming bytes from the SIM module, and if there are, we read them in, and we give those bytes one by one to this function called pass AT_text, which is the main part of the program. And then we this just lets us type things into the serial monitor, but I wasn't really using that for this sketch, so you could probably just leave it out. Well, this is not necessary for what I was just showing you before. Alright, so this is the main meat of this sketch. So we're going to take a byte. Oops. We're going to take a byte, and depending on what state we are in at the moment, we're going to pass some text. Hold on a second. Let me just, since I've gotten rid of that display there, I'll have to show you this other one. This will just let us see what we're dealing with a little bit clearer. There we go. Okay, so this is the kind of text that we're going to have coming in to deal with. So if we are in the first state, where we are still trying to figure out which kind of a message we're dealing with, there's a number of things we can see, but if we see a new line, we just abandon everything and start again, so that's going to reset the buffer. Otherwise, if it's not a new line character, if we're at position 3 in the buffer, and this is string compare function, this just means that if the string in the buffer is equal to AT plus, and we're at position 3, that means we are, for example, we've just got to this point where the cursor is there. Hope you can see that. The cursor is flashing there. So that means we're at this point, and we know that anything else in this line we can just ignore. So we set the state to be ignoring command echo. Alright, otherwise, if we are at position 6 in the buffer, we are, for example, if it was this one, we would be, well, let's start with this one because this is the first notification that comes in. We would be here. Again, I hope you can see the cursor in the video. So we've just written 6 characters. Now we can check to see if we have one of these messages types that we're interested in. So we do a string compare again to see if the string in the buffer is equal to +CMTI:, and if it is, we put a little bit of text on the serial monitor to say what's going on, and then we switch into state read CMTI storage type. So now we're going to be looking for whatever this is here, the next part of it. And we do basically the same thing for the CMGR again. And for the CMGR case, we switch into read CMGR status, because CMGR thing has the first piece of that is the status. Right. Where's that there? Oh, okay. So reset buffer here will just clear everything out so that when we do the next time we do a string compare or something, we'll be looking at whatever was coming after the CMGR. Alright, so I'll try and make this as quick as I can, but basically it looks terrible because there's a lot of text and everything, but each one of them is pretty simple. So if we're ignoring the command echo, we basically just check if the byte that we just read in is a new line. If it is, we go back to the default case where we're detecting what type of message it is and reset the buffer, otherwise we don't do anything. So that's pretty simple. If we are trying to figure out this piece here, we know that this is going to have a comma after it, so we check here that if the byte that we just read in is a comma, then we can print out a little bit of info to see what happened, and then we switch into the state where we are looking for the ID of the notification, and again we reset the buffer. So now in this case here where we're trying to find the ID, we would be at this position there, so we've just read in that comma, and the next byte that comes in should be a number. So we read until we get to the end of the line, basically. Yeah, that's right. Because it could be, potentially, you could have it two numbers, two digits. It could be like 15 or 12 or something. So we read to the end of the line, and then we use this ASCII to integer function to convert whatever string was in the buffer, which should be a numeral, and then we print that out, and then we store this as our last received SMS ID, because we're going to use that later to delete the message, and also here we're going to issue a CMGR command to tell the SIM module to give us the content of that message. So in here we're doing a print and a print line to the SIM module with the CMGR command there. Now I had a lot of problems because in my other sketch, in my last video, I had some delays in there and it wasn't an issue. But it seems that if you delay here, the SIM module feeds the message content back to you very quickly, and it fills up the software serial buffer before the software serial buffer can be emptied to use the content of it. So just don't do a delay there and you should be alright. So then we go into the state where we are, wait a minute, oh yeah, so we just return back to the default state there, detect message type. Alright, there's a few more, but all these ones are the same, so I'll just skip over them. So CMGR status, we look for a comma, so that means that we are going to be here. Cursor will be there. So we're looking for a comma to let us know that we've just read in this piece. And likewise, I'll just scroll through these because they're all the same. Again, we're looking for a comma at the end of the phone number. And then we are looking for a comma again at the end of the something. Oh, I forgot to look up what that is, but there's another field in here which is just an empty string. Every time I've seen it, it's just an empty string, so I can't remember what this was supposed to be, but it's a something, and it has a comma at the end of it. And then after that we'll be looking for the date, and as I said before, the date has a comma in it, so we can't really look for commas, but we can look for a new line character which will let us know that we've finished this whole line up to that point. And then we can start looking at the content. Let me just go back up a little bit to where we were checking the phone number. So when we get the number of the cell phone that sent the text, I'm just hard coding this to say valid sender equals true. I'm not doing a check for it. But if you wanted to check and make sure that only people that you wanted to allow to do this were sending you texts, then you could uncomment these two lines here, and then you would do a string compare on that buffer content to see that it was the right phone number. Okay. Right, so the last thing that we do is, now we know that we're going to be at this point in the content. So whatever comes in the next line is going to be the instruction that we typed on our phone to the Arduino. So to read this in, we just look for a new line. We're going to read it all in one go and just print it out. And then we're going to call this other function down the bottom called pass SMS content. So I think most people that grab this sketch off my website and try to use it, the only thing that you'll really need to change is perhaps the digital pins that you're using for whatever output you do, and then also the contents of this pass SMS content you'll probably want to change as well. Alright, so after we've passed the content and done something with it, then we issue a cmgd for delete command to delete the text that we just got, and then we go back to the default state and reset the buffer. So the last bit of this sketch, if you're still listening, is where we actually do something interesting with the content of the message. So at this point there's no parameters given to this function, but we know we have this variable called buffer which has this text in here, in this case R0. And you can arrange whatever kind of protocol you like for this, but I just use the 2-character codes like R0, Y1 and so on. So I'm going to loop for as long as I have 2 characters in my well, this is just a reference to a point in the buffer. So as long as I have 2 characters left in my string that I'm looking at, I'm going to look at the first one and the second one, and I don't think I need to explain this really, do I? But basically, if the first character is R and the second character is 1, we digital write high, otherwise we digital write low. And the same case for the Y for yellow. So that's about it. Not sure if I really need to explain anything else. Oh, we could just look at this running. Let's do that. So just see what kind of a result we get if we are looking at it while it runs. Let's see if we can look at the LEDs as well. There we go. Need to shade them because they're not very bright. So I'll just do red LED off. R0, send, and we should see something showing up in the serial monitor. Okay, red LED turned off, that's good. So again, this probably doesn't need much explanation, but this is just a little bit of logging to show you what point it is at and what the results were from that message. So there it is there, content R0, all works quite nicely. So yeah, let me know how this goes if anyone uses it. It's probably not too complex. Like I say, you don't really need to touch any of that main pass.at text function. It's just the thing at the bottom. You should be able to get away with just putting something different in there for your case. Oh, sorry, just one thing I should clarify. If you do use this little bit of code here to check if the phone number is a valid sender, the way I've got it right here at the moment is not going to work, because if we look at the number string that we get in, it actually includes the quotes, because that was part of the where is it? This is how the string looks when it arrives, and we're actually including this comma in those quotes as well. So we don't really want to do that, but we would have to do something like this, check for all of that plus that comma at the end. So if that was your phone number, you would have to also do that to include the quotes, and like that. So I'll fix that when I upload the source code, but that's what you should be checking for if you want to do that valid sender check. Okay, I think that about covers it. So thanks for watching, and I'll see you next time.